Hello class, in this video I'll be applying some of the rules that you learned to find the antiderivative of a function. Let's begin. Find the indefinite integral of this following four-term expression. Okay, so what I'm going to do is I'm going to label the function inside the indefinite integral. I'm going to label that f of x. And the goal is to find a function, which we'll label capital F of x, such that the derivative of capital F of x is equal to the given function. And to do that, I'm going to separate this into four separate terms, like such. And now that I've separated this into four separate terms, what I can do is I can identify the type of rule we need to use. So it looks like the first two terms are going to require the power rule. And remember what the power rule states. I have it in the top left-hand corner. The antiderivative of x to the nth power is equal to x n plus 1 divided by n plus 1 plus c. The third term, this is the natural log. And the fourth term, this is the constant rule. And now that we have all of our rules established, I am going to apply those rules, starting with the power rule. So notice I'm going to add 1 to negative half, and then divide this whole expression by negative 1/2 plus 1. And I'm going to do the same thing for the next term. This will be x raised to the 2 plus 1 power divided by 2 plus 1. Next is the natural log rule, and the indefinite integral of x raised to the negative 1 power. That is natural log, so that's the natural log of the absolute value of x. And the fourth term is the constant rule, so this will be plus 3x. And then I'm going to add c at the end. Okay, so after cleaning this up a little bit, what we have is the following. And when you take a number and divide by a fraction, you have to multiply that by the reciprocal. So I'm just going to shrink this up a little bit and provide some space. So in this case, capital F of x is going to equal 8x to the 1/2 power plus x to the third power divided by 3 minus the natural log of the absolute value of x plus 3x plus c. And you can check your work by asking yourself, does the derivative of capital F of x equal the given function? And the answer to that is yes. Okay, so now example number 2 in this video. Find the indefinite integral of this three-term expression. So just like the previous problem, I'm going to separate this into three separate indefinite integrals, like such. Next, I'm going to identify the type of rule we are going to need. And it looks like the first two terms require the exponential rule. And the last term requires the power rule. And again, our goal, if this is lowercase g of x, our goal is to find a capital G of x such that the derivative of capital G of x is equal to lowercase g of x. So I'm going to go and apply those rules right now. So this will be 1/5 e to the 5x plus 3e to the x minus, and the power rule we will do in blue. Notice I'm adding 1 to the exponent, and then I'm dividing by -5 plus 1. And I'm going to go ahead and add the c right now so I don't forget. So if we clean this up, this becomes 1/5 e to the 5x plus 3e to the x minus 2 times x to the -4th divided by -4 plus c. So it looks like capital G of x is going to equal 1/5 e to the 5x plus 3e to the x plus x to the -4 divided by 2 plus c. And then you got to ask yourself, does the derivative of capital G of x equal lowercase g of x, or the given expression? And the answer to that is definitely yes. So we are done.